what are the things that we have? Okay, firstly, this is the rocket. Let's say I draw a free body diagram. We know that a rocket has mass, weight, sorry, so I will have, this is W, right? Clear? Now, they say that, according if you read that, the space shuttle has a mass and it can produce an initial upward force. Initial upward force. This is coming from the rocket, the jet. Okay, so if I were to do that, okay, the initial upward force, remember, is the rocket firing off a fuel, hitting the ground, and the ground is actually producing the upward force, pushing the rocket up. Do you understand that logic? Same as when we jump. So there is going to be an upward force that is going to be upward. So I'm going to just draw it like that. Now, should I draw it very long? Is this logical? Is it supposed to be longer than this? Yes, has to be the case. If the upward thrust is not longer than the weight, we have a problem. It cannot lift off. Okay? So, okay, so now we move on to, now we understand that. How do we get the net force? Okay, I'm always focusing on net force here. How do we calculate net force? So, firstly, remember Newton's second law, the net force is always the change in momentum over the time, right? In this case, because it's written that, calculate the speed at which the gaseous fuel must be ejected. Okay, so we are talking about the velocity here that you have to find. Alright, so the net force, okay, is related to a change in mass over time. Where does this change in mass come from? It comes from the ejected fuel above. Get it? Right? Because when you have so much mass, you eject this amount. The change in the mass is the amount that drop off, right? The change in the mass. So this change in mass is just the 4 tons that dropped out. But this is over time. And because they already give you that is 4 tons per second, so it's 4,000 kilograms over 1 second. Understand? SI unit, everything SI unit. But over here, you notice, from the force net, I wrote there Fi minus W. Why? Because if you look at the diagram there, the force up is your Fi. Correct? Minus away your weight, which is in the opposite direction. So by doing this, you substitute the values here, 30.8 times 10 to the power 6. Okay, where did I get 30.8 times 10 to the power 6? Above there. It is the initial thrust of 30.8 mega newtons. So mega is 10 to the power 6. Minus away the weight of the space shuttle, which I took as 2.04 times 10 to the power 6. Okay? And I multiply it by the gravitational constant of 9.81 to get the weight. When you minus this minus that, you equate it to this. When you solve for it, then you get your final working, which is there.